transmitted wave, PT, has to be PT, that is the magnitude of transmitted wave, exponential minus j omega t, and then I can write minus k, say kt, that is the wave number in the medium over there. Kt, and then I have a in x direction, that is cosine theta t no, sine theta t, right? Cosine theta. Cosine theta tx. I'm confusing. And then I have minus kt sine theta t y. That is the wave propagating on the right-hand side with the transmission angle theta t. Okay? The velocity, on the other hand, in x direction is what? Pt over rho 0 c0, right? And cosine theta t, right? And exponential minus j, say this is theta, okay? Capital theta includes all the omega t, kt, something else. That has to be same as on x equals 0, the velocity of a plate that has magnitude a, that is complex, exponential minus j omega t minus kb y. The velocity is the rate of change of displacement, therefore I have to write over here minus j omega. Right? So I can write here the PT is equal to rho 0 c0 minus j omega a divided by cosine theta t and exponential minus j this, right? You're reading a book. Okay. Now, cosine, I have a cosine theta t over here. And in theta, there is a term minus omega t and minus k t cosine theta t x minus kt sine theta tx. If you like, we can write this is just k0 cosine theta t, whatever, because kt only depends on the medium. Okay? Now, this is cosine theta t. And interestingly, cosine theta t square is 1 minus sine square theta t. Right? And we know that kt sine theta t has to be equal to KB. All right? So if KB is smaller than 1, then cosine theta t has a real value. That means, because cosine theta t has a real value, that means there is a propagation in x direction. In other words, there is a transmission in x direction. But if KB is larger than 1, then this formula says that cosine square theta t is less than 0. Therefore, cosine theta has to get some imaginary part. That means there is no propagation in x direction but evanescently decaying wave in x direction. But there is this is to be y. But there is a propagation in y direction. Right? So looking at K, what is KB? That is omega over CV. Right? That is omega over CV. So, if CV has a value that makes KB greater than 1, okay, then what happened? There is an evanescently decaying wave. If CB, in other words, supersonic, for example, that means that CB is greater than the speed of sound, then what will happen? If CB is smaller than C0, then what will happen? So, depending on the value of a CB, we may have exponentially decaying curve in the vicinity of a plate, or we could have a propagation in x direction. Okay? That's very interesting phenomena. Very interesting phenomena. So that summarizes what happened on flat surface of discontinuity if the surface of discontinuity is plate. Okay, two things is important. The one thing is the transmission loss. Transmission loss is same as what we obtained for the partition. The only difference is partition impedance, ZP, is different. Okay, the ZP for general partition is, what was it? ZP has three contributions. One comes from damping, RD, and the other one is minus J omega M that come from the mass. The other one is omega over S over omega related one that comes from the stiffness. But for this plate, instead of the term coming from stiffness, we have a term coming from bending rigidity. That's the only difference.